and welcome. Today we're going to show you the result of our collaborative work of two teams. Shortly about us, my name is Alexey.
And I'm Krzysztof. I am Krzysztof from Getting Data.
And shortly about KSL, just to give you an idea about the company. So KSL is the largest GSM operator in Kazakhstan with over than 10 million active subscribers. And we like innovations, we like open source, and we like to develop new things. So, as you can imagine, any telco has really various data sources. From the short messages platforms, from the voice usage, the data usage, roaming, location-based services, and many more. So there is a real business need to aggregate all those events and react according to some business rules, some predefined business rules, and upon this trigger some third-party platforms, such as some marketing platforms, maybe some technical, some alerting, emailing, etc.
And what's important, it's a complex event processing for those business rules, and it has to be real time, right?
The real time semantics is like essential here. So let me give you ideas, a few use cases about the business needs. For example, imagine our subscriber that top-ups his balance too often in a short period of time. So we can quickly identify such events and advise to our subscriber to a better tariff, or maybe to turn on some auto payment services, so he wouldn't spend so much time do it manually. And by the way, a little spoiler, here is the screenshot from the platform we built. This is the real business rule that's defined by the business user and then run on our platform. So, another case is roaming, when our subscriber arrives to the new country and his device is registered in our partner's network. We would get this event and propose him some additional services that would let him spend less money. As you all know, the roaming is pretty expensive. Another usage cases which are really important is fraud case scenarios. And here's where we should react really quickly, because the later we react, the more money we can lose. So imagine another case with roaming, when our subscriber registered in a partner's network, but the subscriber's balance is at zero level or on some low level. And we got billing and charging events from our partner really late. So the subscriber can spend lots of money before we just block him. And that's the fraud case scenario. And we should avoid it. So we defined the business needs, and actually KSL already had this system installed, but the problem was it didn't really work. And the reasons to that is it was an external vendor solution, which was a black box. We were limited to some small configuration and tweaks. No new scenarios without the change requests. We couldn't develop something by ourselves. It had real scalability issues. We were limited to 2K, maybe 3K on best case scenarios, events per second. And as you will see later on, that's not enough. And the biggest problem was it was also not reliable. There are some accidents when it was down for hours, and we had to ask the external team to properly switch it on again. So we decided that we need to develop our own solution, and we calculated the numbers we will need for that. So those are the main numbers. As you can see, we got more than 165K events per second and about 22 terabytes of data. Now, as you can see, that was obvious that the old tools wouldn't work for us. We needed some new tools. And yeah, we knew that gonna be some tools from big data world. The problem was we didn't have enough expertise in this, and we needed to start fast, and there was just no room for errors. And that's why we decided that we need some support from the people who already got experience in this world. That's how we found our partners getting data.
Yeah, and we are thankful because it's our passion to build systems like that with, for example, Flink as one of them.
So together we designed a new system. Here you can see an overview of it. As you can see, there are a few main parts. It's the ingestion component where we get all our events from various data sources through so many protocols. It's like HTTP, FTP, just external storages, message queues, and so on. We needed a reliable data pipeline, as we call it, an events hub. Obviously, we needed some engine to run our business rules, and also an ingestion tool to actually trigger third-party platforms or send some alerts or some marketing advertisement. So that's our choices. Some of them were easy choices. For example, Kafka. At that time, there were no competitors to that with such a load. We also chose Knife5 for ingestion and outgestion, and that worked pretty well for us. It's quite flexible and configurable, and has already lots of predefined models that you can use. And after a few other variants, we chose Flink because that's the only tool that could withstand such a load with real low latency. And it also had really advanced tools for streaming semantics. We also needed quite a few tools that would allow us to monitor and operate our platform. So we chose Elasticsearch for logs shipment and analysis, and we got InfluxDB and Grafana for metrics. We built, as you already seen, our own admin UI tool. That's the tool for business users, where they can start new business rules, business triggers, reconfigure them, stop, redeploy, etc. And the free API, our tool of choice for authentication.
And we attached to that, of course, a data lake to support other systems. Yeah, Flink, events processing is a core, of course, but there are other use cases, like you want to keep the history in an archive, you want to allow analysis of that data with SQL or with data in data science world with more flexible approaches like Spark or with notebooks. And yeah, so we were able to attach this data lake pretty easily by pulling all the data from Kafka. And we also wanted to allow other use cases. One of them would be interactive BI on the data, where you can slice and dice data, drill down interactively in milliseconds time. And for that, we used Druid, the column-oriented data store, to collect all that data. Yeah, let's zoom in a bit on how we implemented our processing flows. It is worth mentioning that we tried to be streaming only, right? Try to be. I'm not saying that we are 100% that, but we try to be streaming only, and that means we even ingested FTP data files, which are usually produced by in batch, as streams, right? So we took in NiFi was collecting those FTP files, transforming them to streams, and saving to Kafka. As raw events, that means the same events that were in the FTP files, that were like XML or other. And then Flink transformed these events to more proper format. I will say that later, but it's Avro that is more optimized, right, fast, and so on. Also saved in Kafka, and it happened for other sources. Sometimes there was no transformation, right? Sometimes NiFi was doing transformation. And all this data is ingested to the job, which is like a central thing that applies all those rules. I'll speak about those rules in a second. And of course, this job produces notifications as a stream in Kafka and sends it via NiFi to multiple other systems, right? And yeah, maybe you've seen our presentation, by the way, on a big data tech in Warsaw. This is a new part that we included for Flink Forward, exclusive. And for you squirrels, some streets, I would say. The dynamic rules design, our, I think, unique feature that we implemented in our system. This was inspired, for example, by the system Arbia created by King. Now, I think there are more implementations of systems like that. And what is that about? So the key points, the key requirement was that we want to run really even hundreds of those triggers, those business rules, right? Business defines them, you know, fraud unit, marketing unit, whatever unit, right? Operations and so on. And the typical approach is in Flink that you develop a job or a topology, right? Flink topology per your rule, whatever, per your processing. So in our case, it would be job per rule or topology per rule. But that would not work in our case, right? We will have hundreds of topologies running on our Flink cluster or Yarn cluster, actually. And that will multiply resources cost, right? We will have, you know, there is a overhead for every topology, networking, and everything. And what is even more important, we will have to pull data, for example, from Kafka hundreds of times, because there are hundreds of those rules. And actually, those rules consume the same data, right? The same data sources, the billing, the roaming, the whatever. So they will pull in parallel this data. What for, you would say? And they will create state multiple times, right? They will replicate state in every job. For example, balance of a user that is used for many rules, they will accumulate this balance from the events, from the change events in every of those jobs, replicating the memory that is used. And last but not least, we will have to start a rule, you will have to deploy a job or deploy a topology to a cluster, and that's always an operating overhead. So we wanted to solve these problems. So our approach was to actually run one job, one topology, to execute all the triggers, all the rules, and to consume all the sources, right, in this single job. Of course, we prepared trigger implementations, coded still in Java. These are like templates that are waiting to be launched with some configuration. And we can launch those trigger with templates by issuing a command to the system that say, hey, start this template with this configuration. For example, monitor balance, and if it drops below this and that value, then alert us, right? Thanks to that, we are really able to run hundreds of such rules efficiently, even on a really small cluster. So for example, for a long time, I think still, we run 4 nodes cluster on this 160,000 of events. I would say it's impressive. Yeah, a little bit deep dive into how our job looks like, right? The core thing, skipping some less important details, is the co-process function, right? That applies the triggers. It's an operator that is keyed by user, so it's parallelized by user, I would say. And it's a co-process function because it accepts one input, all those data, right, the events, and also it accepts control topic. It's a separate topic that has those commands. Please start this trigger, please stop that trigger, right? It comes externally. And what happens inside? We take all those events, and to be able to apply complex event processing, we cannot just do rules that allow out of orderness or late events. It's actually extremely hard to do pattern matching, right? Because it is pattern matching on unsorted data. So we first sort by time inside of that operator. As we sorted the data, we can already deduplicate that because there are duplicates produced by Kafka sometimes. And then there's a router component that routes the data to triggers that require this data to be able to apply the rule, right? And that all happens in a single operator in Flink, right? It's not like it's an implementation detail that these are separate classes or whatever. So we have multiples of those triggers. Let's say there are enabled triggers, right? Each of them can keep the state, but plus there is also a different type of, we call state updaters. It's not a trigger, but doesn't produce any notifications. But what it does, it creates state, right? That is shared among the triggers. So for example, balance, right? The user balance. There's a state updater that consumes events that change the balance, right? And updates the state, and all the triggers just look up the state, right? That was really possible only if we operate in the same operator in Flink. All right, now some pros and cons, because there are cons as well of that design, right? Big pro, right? We share resources again, CPU, RAM, state, and also shuffle, right? Because there's only one time shuffle by by user ID, and that's all of all the data, right? It's not per job, it's really once. And we pull the data from Kafka once, right? Those 160,000 of events, just once. If we had to run it per job, there would be hundreds of that throughput, I would say. We share the state, so that allows us to build, that allows us that rules don't have to implement state building, like accumulating balance of the user to be able to apply the rule. That's also a great thing. So the implementation is shared. And yeah, and the good thing is that we don't have to restart the job to start new rules, right? Assuming they are pre-implemented, but we start the rules by just submitting a command to a topic. So we quickly could give this possibility to business, right? No IT was involved. Through admin UI, they could submit new new rules. But there are cons, right? One bad rule affects the whole system, right? You write a new trigger, new rule, but somehow it uses too much RAM and it goes out of memory. The whole job goes down, right? That's a big issue with that system, with that design. There are also watermarks are shared. I'm going to say that in a second. You still need to code rule templates, and you need to code them in Java. So for example, we cannot use, in this design, we cannot use SQL, Flink SQL, because Flink SQL does not, it requires to deploy topologies, right? It cannot just, we cannot leverage that here, right? We will have to implement our own SQL engine if we would like to. The same with Table API, the same with CEP, right? Complex Event Processing Engine. We cannot use that, unfortunately. And it can be tricky to debug as well. The code is shared, right? The code base and the code paths actually are also shared. You cannot just breakpoint easily on a single job and analyze how it behaves, right? But it's okay. I said that about shared watermarks. So the problem is here that when there is one source which is highly unordered or late, right? We had such an issue that it was like 7 minutes, 8 minutes late. And it was one of the source to hold triggers group. All the notifications had to wait as much time, right, until watermarks progressed. Because as the sources were unioned, right, the watermarks were unioned as well. The minimum of the watermarks was the watermark of the whole data. So our solution was that we actually separated the triggers group. And so in fact, we don't launch one topology, but we run 2 topologies or more per trigger group. And one topology is accepting those unordered late data, right? And of course, produce late notifications. We cannot work that around. But the other group can accept that requires only fast sources, still runs correctly and gives low latency notifications, right? In matter of seconds. So our rules can launch in matter of seconds. Another issue is that's a technical issue you might stumble upon if you design something like that, is that you join in with slow changing streams might be problematic. So for example, this stream of the control stream is slowly changing, right? The events don't happen often. So if you don't, the event doesn't happen, there's no watermark produced. And that actually makes the whole job, the whole job cannot progress because watermarks don't progress. But the solution that we had or workaround was to actually ignore watermarks from the control stream. So like emit a watermark long max, right? Max long value. But that of course also disables few features like you can the reprocessing is not deterministic anymore because Flink will just take everything from what is in control stream and apply it even to events older than that. Older than the events in the control stream. So yeah, that would change the behavior. I can design that later on the paper, if you like. Yeah, there are a few things that it would be nice to see in Flink, and maybe we will be able to develop that, which could help us design a system like that. So dynamic topologies would be great. Like we could attach a new topology or a new branch to existing topology that actually receives the same data, right? So that way we can dynamically deploy new parts of the topology that consume the same data. So that inputs are actually shared between topologies, right? The great thing. So that you pull the data once from Kafka and you fan it out to multiple triggers, right? Somehow there could be a cache inside of Flink that is able to save some data. I mean, pull the data once, save it, and distribute that among multiple branches of the topology, right? But that, of course, it also would require cheaper topologies so that the overhead of topologies is not big. And what that would enable is actually dynamic SQL. So you can launch multiple SQL queries, right? They are lightweight, right? And they can launch instantaneously, they can be stopped, and so on. So, and then our rules could be defined with SQL, for example, or other DSL, whatever there is better for defining business rules.
So let's zoom out and discuss some decisions we made while we were building this system, and maybe you could find it useful for yourself. So really high overview. We use Apache Kafka for Event Hub, and it does a great job. We couldn't find another tool that would fit here. And we're pretty happy with Apache Flink as well. And what's really important, we are getting the streaming first approach. And as you will see here, for performance reasons, we try to consume all the sources, even the traditional ones like relational databases, to Flink itself. So,
and create lookups inside of the job, right? In the internal state.
That's allow us to withstand all this high load. Also, for performance reasons, as one of the key requirements, we chose Apache Avra as our serialization and deserialization library. And we serialize it to Apache Kafka in Avra. Yeah, that's it.
Yeah. A big requirement was also to make all the system easy to use, right? Also by business users. And we think we achieved that by using, for example, NiFi for data ingestion, right? So non-coders can actually define the data flows, new data sources. It works pretty nice. There are a few caveats, like, I mean, not all the components are ready to fulfill your business requirements, your FTP kind of FTP, or your way how files in FTP appear. But I would say that NiFi is also, it's not only a toolkit, it's also a great framework where you can develop your own new components and deploy them and use them in NiFi, and that works pretty well. You could think like, hey, if NiFi is so good, why do you use Flink for SEP, right, for those rules? Why not use NiFi then? No, that's not a good idea. NiFi, I mean, implementing business rules that analyze patterns, right, that keep some state and so on would be extremely hard in NiFi and to make it reliable. We also created this web UI, right, for configuring triggers. That was also an important part. The reliability was also extremely important of our system, and I think we achieved that by running Flink on Yarn. We didn't go any fancy like Kubernetes, I mean, at least not some time ago when we were starting. But it runs really stable, I would say, right? Yarn the implementation resource manager is really stable. And we use HDFS as a file storage. It's also working very good, and we have several years of experience using that in operations, and so we're confident about that. And all our components were deployed with HA, right? There are no single point of failures in our system. They were rather replicated or even distributed, right? Running 24/7, right? We are rarely called for any issues. And yeah, InfluxDB and Grafana worked very good for monitoring of our scale. And ELK for logs collection was also pretty good, right? We don't produce a log per event. That would be too much for our ELK stack, but we still produce pretty high load of logs. Yeah, the extensiveness was also important, and I think that we achieved that. One platform for the whole enterprise. We quickly attach data lake, we quickly attach all of the BI, Druid, and all without affecting other systems, thanks to the coupled components, Kafka in the middle of the processing, yeah, and cost efficiency as well. We use open source. We didn't use any paid systems. HDP as a license-free distribution really works great. And we started with just a bunch of servers, so really low cost.
So there were two remotely working teams. We constantly shared our experience in our fields of knowledge. We implemented a bunch of tests, like not only unit tests, but which is really important is end-to-end tests, and that's really helped us with system overall stability and robustness.
We created mock systems for the sources, for the things.
Yeah, We used just classical agile practices as everyday stand-ups, and we used DevOps tools heavily and automated our tests, deployment, etc. All of this helped us to deliver the first production triggers less than a few months.
Yeah, that was a big achievement we are proud of.
So now it's time to talk about the bright future of the platform. We are planning to add even more data sources. We need to more work on our data lake. We want to build a customer 360-degree view. We are looking for the ways to make more money on the data we get. And yeah, as always, the machine learning, we want to predict some events, maybe some subscriber churn or some other events that our business will need.
Yeah, and we believe that the platform, as we built it, right, and the technology stack that we chose allows us to do all of that. That's a really great thing, confidence.
So we hope you have questions for us, and we are ready to answer them.
Yeah, thank you very much. Are there any questions?
Hi, great talk and beautiful slides.
Thank you.
Just a small technical question. What do you use to collect the data you put into InfluxDB?
What did we use to connect?
To collect
data in InfluxDB?
Yeah.
So we use exporter in Flink to export data to InfluxDB directly. And in NiFi as well, we have these reporting tasks, as far as I remember they're named, which are also reporting metrics directly to InfluxDB. We don't use any intermiddle state, like Kafka to collect all the metrics. We don't do that yet.
Okay. And you don't collect from other systems?
From the other systems as well. Sorry, I was looking at the application level. Yeah. We configured Hadoop and other components also to send metrics to InfluxDB.
Okay, thank you.
Hey there, nice presentation, thank you. Just two very short questions. Having in your control stream the maximum value of watermark disables you any further control, so you will not be able to emit any more watermarks as far as I remember. So then you lose control of the control stream, really. That's how it works? Did I get it right?
Yeah, I mean, we lose any possibility to, for example, because this is a join of the streams, right? To do a kind of a window join, I would say, of those two streams of the control and the data. So that, you could think that, hey, I want this trigger to be applied only on the new data, not the old data. We cannot do that, for example, right?
Okay, thank you. Just the second one, very short. What's your experience with the Influx running in high availability? Can you share some numbers?
Actually, okay, you got that. We are running that on a single instance.
Thank you.
Free version. Good catch.
What was your process to decide on the different technologies you used, and especially Flink? Because you mentioned several times that you ended up choosing Flink, but what got you to Flink?
So we analyzed, I'm not saying that we used in production, but we analyzed different technologies, Spark streaming, Kafka streams, right, and Flink, at least those three.
Even Apex.
Apex as well.
Yeah.
With Spark streaming, we actually used the old Spark streaming, and we were very dissatisfied, in short. Now, we could consider Spark structured streaming, right, definitely, but at that moment, we were rather choosing, the Spark streaming was the only one. We actually looked at the community. I looked at really big use cases.
The APIs, quite a few benchmarks.
Yeah, companies that use it, Netflix, Uber, and so on, right? that supported our decision. And yeah, we spoke with data artisans as well, and we got like a confidence that it is really a production-ready technology. Not, I mean, really can handle this load. And what we really, really liked is the semantics, right? That it allows, right? That it allows you to go high level. But it also allows you to go low level, really. And we do use low level APIs. We use process function, co-process function, and so on, right? That would be, for example, impossible to do in sparse structured streaming, as far as I know, right? And we wanted to be also independent of Kafka, right? We like Kafka, we use it, but it would be good to be, not to be tied to it. So, for example, we didn't want to use Kafka streams.
Any more questions? Not? Thank you again. And